Hey guys, welcome to day 23 of our Leetcode challenge. And today's problem is problem number 201. It is bitwise ANDing of numbers range, which means given a range of numbers, you need to do bitwise AND on each of the number, right? You have m to n in the range, and you need to return the AND bitwise AND of all the numbers in this range. So let's look at 5 to 7 example here, which means all numbers from 5 to 7 needs to be bitwise ANDed. So let's get the bitwise representation of 5, 101, 6, 110, 7, 111, right? We need to AND all these bits. So ANDing 1, 0 gives you 0, ANDing 0 and 1 gives you 0 again, right? And ANDing all these bits on the same position here gives you, and ANDing all these 111 bits will give you 1, right? So this is actually comes out to be 4 in decimal representation of the number, right? So this matches the answer. One thing we can do is, if we go by the brute force approach, of course, we need to just do from for numbers from m to n plus 1, we just do like answer equals to answer bitwise and number, right? But if you see the range of the numbers, this is pretty huge, right? This is pretty huge, and it will surely give you time limit exceeded. What you can also do, that once your answer becomes 0, that means you cannot, that there is no point in ending into more numbers. You can return those answers, but those are like small optimization, and it won't actually improve the time complexity of your algorithm by much. So it will again give you a TLE. Okay. So what we'll do is we'll analyze this uh, by few examples and see if we can find any pattern in this. Okay. Let's say we have the example as 8 to 12, right? 10, 11, 12. Okay. Let the bitwise representation of these numbers. Okay. Now see that if you bitwise AND this, so you get a 1 in your answer only if all the columns in these range of number is a 1, right? So this is one thing we have learned. All columns should have a 1 for the answer to have the 1 in same place, right? First of all, in order to reach from 8 to 12, all the numbers in this range, the bits should flip somehow. This bit should increment to 1, right? And this bit would change to a 0 and a 1 and a 1 and a 0 again. The numbers that change anytime, and since the numbers are only zeros and 1, if the bit change anytime, then the answer would always have 0 for that position. If the bit do not change on any position, then you can safely assume that bit would retain its position in the final answer. If you see a longer example, let's say 1 0 1 0 1 0 1 1 0 1 1 0 1 1, right? This is our m, this is our n. We need to list down all numbers from this to this into a bitwise AND, right? But let's say the difference in the number is in this bit, right? For these m, and iterating from n to n, this particular bit needs to flip to a 1, right? So there will be a point in time where this particular bit x will increment to 1, and the remaining bits will become zeros, right? These four positions, right? And you will iterate something like this, right? Until you reach this point 1 1 0 1 1. But these bits, these bits do not change at all from m to n, right? So these are perfectly fine, and any bit that changes from 0 to 1 or otherwise will be substituted as 0 in the answer, and all the remaining bits would also be need to be zeros, because there will be a point of time where the switch happens and all these zeros come, right? So from m to n, all the numbers would have a common prefix in bits, and these are the only bits that will remain stable in the answer, and all the remaining bits from m to n will get to 0, right? So what we need to do in our solution, is get bitwise representation of m, get bitwise representation on n, and find the common prefix. Now, I will show you my code that exactly what I did, right, following the algorithms. I extracted the bitwise representation of both m and n, and extracted the common prefix. On top of that, I'll show you a better way to do this using the shifts operator, the bit shifts operator here. So let's look at the code now. First, we need to define a bit representation function, which will give us the bit representation of any given number. So I'll put the bits in an array, right, and I'll return the bits. Now, while there is a number left, then what I do is I extract out the last rightmost bit. So if x modulo 2 is 1, then I need to append 1 in the end. If it is 0, the remainder divided by 2 is 0, then I need to append a 0, right? And then I need to divide x by 2. Okay, now this bits function will actually give the reverse interpretation. So reversed, right? So if you have 4, then it will give you 0, 0, 1. Now we just need to do a reverse on this to get the 1, 1, 0, right? So list of reversed bits. Okay. Now let's get bit representation of m. Let's get bit representation of n, right? And so once you get it, so let's say you have 4 and you get and m is equals to 4 and n is equals to 8, right? Then you see that we don't have a way to represent or to pad 4 with a leftmost 0, right? So if this padding is needed, which means we don't have any common prefix, right? The length of the bit representation is not same, so the ending of all the bits will be 0, right? So if length of bm is not equals to length of bn, then return 0. Okay. If they do match, suppose this were to be 7, then this will become 111. Now what we need to do is we need to fill our answer for I in range. We iterate over the bits and see if they are equal. So this is where we are extracting the common prefix. Okay. Now if bm of I is not equals to bn of I, then we need to break here, right? If bm of I is same as bn of I, right? But if it is 1, which means bn is also 1, then we need to construct our answer, right? So either we can construct our answer in bits and then convert to decimal system, or we can directly convert it into decimal here. So what I'll do is I'll do the direct construction of the decimal answer here, right? And we need to define what power we need here, right? So return answer here, right? Now we need exactly how much we need to increment our answer with the power, right? So the power is actually length of bm minus I minus 1, right? So for first bit in 4 and 7, we should add the answer with it 2 to the power of 2, right? Which is 4. Now here, this power 2 is actually length 3 minus I, which is actually length 3 minus I, which is 0 minus 1, and this equals 2. Let us run this code and see. Okay, I think we need integer division here, otherwise it will just go on forever. Okay. Okay, cool. But this is not the actual solution I wanted to show you. So you can do this thing, but you can also do this via bit shift operators. So what we need to do is, since we need a common prefix, right? What we'll do is, well, m is not equals to n, and we reduce the n until it becomes equals to m, right? So we'll take out the rightmost bit from n. The rightmost bit to n becomes 0. We take out rightmost bit from m. So so once this is over, answer should be equals to m or n shifted by how many number of while loops we have run here, right? So what we'll do is we'll also count the shifts here, and we'll say shifts plus equals 1, and we'll return this answer here. Okay, let us run this code. Okay, so I'll tell you how it works on the example we have seen: 10101011 and 10111011. This is the example we had, right? So the first three bits are the common prefix, right? So in the first iteration, these two bits, the last two bits goes into null, right? So this m is not equal to n still, right? So we'll keep on iterating in the while loop, but our shift become 1 here, right? Now this bit go, shift becomes 2. This bit go, shift becomes 3. This bit go, shift becomes 4. This bit is iterated and shifts become 5. So our m is equals to n here, right? But what we need is our answer. Our answer should be equals to 101, 102, okay, something like this, right? So we need to append 5 zeros in the end, right? So that is why we are shifting the m by this number of shifts, right? I hope you like our approach to this video. We have first shown you a solution which is more intuitive, and then we have shown you how to optimize your coding skills to implement the algorithm you have in a much better way. I hope you again like the video. Please share if you do. Subscribe to our channel for more daily videos like this. Thank you so much for watching.